Question 12 is transformation. Question asks us to fully describe the single transformation which maps triangle P onto triangle Q. A single transformation is what's required. Now the transformations which are possible to choose from are going to be reflection, rotation, translation and enlargement. We can eliminate an enlargement because the shape is exactly the same size. We can eliminate translation because translation would leave it orientated in the same way and it's clearly on its side compared with this one. That leaves us rotation or reflection. In fact, I can tell straight away it is a rotation because the original shape is like that and the final shape has clearly rotated through 90 degrees. This then allows me to describe the shape as a rotation, and as pointed out, it rotates through 90 degrees and it is rotating in a anti-clockwise direction. The only thing I need to know now is what is the centre or the point about which the shape rotates. There are ways to work it out, but at GCSE it's often more convenient and quicker to do trial and error. I'm then going to pick a point somewhere between the original shape and the image, and I'm going to test the result of a 90-degree rotation. That result is a fair distance from the image, so I'll move it back and I'll pick another point. A little closer, still not there, move it back, pick another point. That time I'm a little high, move it back. Okay, this is the one. The original shape and the image coincide when the rotation is around my pen point. So if I carefully remove the tracing paper, this point here is my centre of rotation, and that is 0, 0. So centre at 0, 0. Part B of the question asks us to translate triangle Q by the vector 4, -2. Now with the vector, the top number represents the change in x and the bottom number the change in y. So this means we go 4 along the x-axis and 2 down the y. So if this is our original shape Q, if we take a random point, let's take this point here, we're going to go 4 along the x-axis, 1, 2, 3, 4, and 2 down the y-axis, 1, 2. So this point here has moved to that point there, and then I can just fill in the shape in exactly the same orientation as it was originally. It tells me to label it R, so an R in the middle of that triangle. In the same way as question A, part C goes in the same way that part A of the question asked for a single transformation, part C asked me to describe fully the single transformation which maps triangle P onto triangle R. Again, if I get my tracing paper, I can easily see that it is a rotation because P, if I rotate it 90 degrees anti-clockwise, I can see that that's what happened to the shape. So it's a 90-degree anti-clockwise rotation. I need to find the centre. So as before, I have my traced image and I pick a point where I think the centre might be and I try and rotate it. That's too far away from the image, so I move it back and I'll move a little bit closer to the image. Possibly a little bit better. I'm going to keep on trying points around here fairly randomly or more systematically, and I'm hoping that I will eventually get to the reflection. And that's it. The original image when rotated about the point where my pen is, meets the reflected image. So this is the centre of rotation. Remove my tracing paper very carefully and mark it on there, and the coordinates of that are 3, 1. Question 13, part A, wants us to find the gradient of a line with equation 3x plus 4y equals 10. The only way we can find the gradient of a line if we have it in the form y equals mx plus c, and m will be the gradient, so we need to rearrange this equation. If I take 3x from both sides, I'm going to get 3x will disappear from this side. I'll have 4y equals 10 minus 3x. If I now divide both sides by 4, this 4y will become y, and this is going to be 10 over 4 minus 3x over 4. I've now got it in the form mx plus c, where c would be this 10 over 4 and m is going to be this minus 3/4. So the gradient must be minus 3/4. Part B of the question asks us to find the coordinates of the point of intersection of two lines. The point of intersection of two lines can either be found by drawing the graph or by solving equations simultaneously. In this case, we use simultaneous equations. Our first equation is 3x plus 4y equals 10. Our second equation is 5x minus 6y equals 23. Now there's no corresponding terms which match, so we must make them match. I'm going to choose to multiply equation 1 by the 6 here, and equation 2 I'm going to multiply by the 4. So that's going to be times 6, this is going to be times 4. So the first equation times 6 is going to give us 18x plus 24y equals 60. I'll call that equation 3. And the second equation here, times 4, is going to give us 20x minus 24y equals 92. And that's our fourth equation. We now have corresponding terms there. They're opposite in sign, so we can add the two equations together, and this will give us 38x. Those will cancel out because they're in opposite signs, and this will give us a total of 152. Dividing both sides by 38, this will give us x equals 152 over 38, which equals 4. That's our value of x. Now we've got our value of x, we substitute it into equation 1. So instead of 3x plus 4y equals 10, we're going to have 3 times 4, because x is 4, so it's 3 times 4 plus 4y equals 10. That gives us 12 plus 4y equals 10. If I take 12 from both sides, that disappears from this side, and I have 4y equals, and don't forget I've got to take it from the right hand side as well, is 10 minus 12, so 4y equals minus 2. Now if I divide both sides by 4, this becomes y equals minus 2 over 4, that is minus a half. I'll write it as 0.5, minus 0.5. So our values are x equals 4 and y equals minus 0.5. It's coordinates they want, so I guess the values are just 4 and minus 0.5.